LEED Green Associate, 50 questions, answers. Question 1. Building orientation considerations for a high-performance building include all of the following except A. Minimize east-west glazing. B. Orient on east-west axis. C. Minimize southern glazing. D. Maximize passive solar heat gain. Answer: C. To minimize southern glazing is not one of the building orientation considerations for a high-performance building. Instead, one should consider maximizing southern glazing. Doing so takes advantage of optimum daylight, resulting in energy use reduction. Minimizing east-west glazing with east-west axis orientation and maximizing passive solar heat gain are all strategies for considerations in building orientation. Question 2. According to the U.S. Department of Energy, buildings consume approximately %% of the energy and %% of the electricity produced annually by the United States. A. 74%, 39%. B. 39%, 74%. C. 23%, 82%. D. 82%, 23%. Answer: B. Buildings consume approximately 39% of the energy and 74% of the electricity produced annually by the United States, according to the Department of Energy. Of that, 33% of the energy is consumed by lighting. Intentionally using energy only where it is needed and ensuring that efficient systems are used to meet these needs are the most effective way to reduce the environmental impact of building energy use. Question 3. Which of the following components contributes the largest percentage of energy use to a building's operating expenses? A. Chillers. B. Boilers. C. Lighting. D. Air handling units. Answer: C. Lighting contributes the highest percentage in the energy use of buildings' operating expenses. Therefore, designing lighting to meet the needs and preferences of building occupants without excess should be a main consideration of project teams to minimize the energy the space requires. Enabling occupants to turn off their lights when not in use can produce significant lighting energy savings. Question 4. Conventional incandescent lamps use approximately how many times the energy to create the same light output as standard compact fluorescent lamps? A. 3. B. 4. C. 5. D. 6. Answer: B. Conventional incandescent lamps use approximately 4 times the energy to create the same light output as standard compact fluorescent lamps. The wasted energy is converted into heat and in many buildings, creates an additional burden on the air conditioning system. Question 5. In many buildings, the wasted energy from lamps creates an additional burden on which system? A. Air conditioning system. B. Ventilation system. C. Heating system. D. Air diffuser system. Answer: A. Air conditioning systems are burdened with the wasted energy from lamps. Incandescent lamps are gradually being replaced in many applications by newer technologies that give more visible light and less heat for the same amount of electrical energy input. Fluorescent light bulbs, commonly used for overhead light fixtures, are available for task lighting and other cases where incandescents were previously used. Optimizing the availability of natural light will also substantially reduce dependence on artificial lighting. Question 6. The prerequisites for the Energy and Atmosphere category in LEED 2009 for new construction and major renovations include all of the following except: A. Fundamental commissioning of building energy systems. B. Minimum energy performance. C. Fundamental refrigerant management. D. Measurement and verification. Answer: D. Measurement and verification is not one of the prerequisites for the Energy and Atmosphere category in LEED 2009 for new construction and major renovations. In this category, there are a total of 35 points available, and of that, fundamental commissioning of building energy systems, minimum energy performance, and fundamental refrigerant management are prerequisites. Question 7. Of the 35 total points available in the Energy and Atmosphere category in the LEED 2009 for new construction and major renovation, how many points can be attained for green power? A. 4. B. 1. C. 1.5. D. 2. Answer: D. 2 points are available for the green power credit under the Energy and Atmosphere category for the LEED rating system. Green power is electricity produced from solar, wind, geothermal, biogas, biomass, and low-impact small hydroelectric sources. It is used to avoid the environmental impact of conventional energy generation, as well as its greenhouse gas reduction benefits. Question 8. What is Green E-certified electricity? A. Electricity provided by the utility company that has rebates and incentives. B. Electricity produced by renewable energy resources. C. Electricity produced by combustion of fossil fuels. D. Electricity produced by natural gas. Answer: B. Green E-certified electricity is electricity produced by renewable energy source, that is sun, wind, geothermal, biogas, biomass, and low-impact small hydroelectric sources, that customers can buy to avoid environmental impact and its greenhouse gas reduction benefits. Green E-certified electricity is a subset of renewable energy and represents renewable resources. Green E is the name of the company that provides independent energy source certification and verification and is recognized as credible by the USGBC. Question 9. The enormous amount of energy that is used within buildings causes emissions that contribute to all of the following except: A. Climate change. B. Fumes. C. Smog. D. Reduced air quality. Answer: B. Fumes do not negatively affect the environmental impact due to energy production. Fumes are usually the result of volatile organic chemicals. Between 1990 and 2006, annual greenhouse gas emissions from U.S. energy use increased by 16% and buildings consuming approximately 39% of the energy and 74% of the electricity. These high proportions of building energy use provide a huge opportunity to reduce environmental impacts on a large scale. Question 10. Which of the following is a necessary component of most air conditioning systems found to be harmful to the environment and human health? A. Petrochemicals. B. Chlorinated hydrocarbons. C. Cadmium. D. Refrigerants. Answer: D. Refrigerants are a necessary component in the refrigeration cycle employed by most air conditioning and refrigeration equipment. Many refrigerants, however, are harmful to the environment and human health, and many deplete ozone and contribute to greenhouse gas emissions. LEED encourages the selection of refrigerants that minimize the impact on the environment, particularly ozone depletion. Furthermore, a well-designed vac system can minimize the amount of cooling and thus, the amount of refrigerant needed by a building. Question 11. When addressing water use for laundry equipment, which of the following categories must also be addressed besides the water efficiency category? A. Sustainable sites. B. Indoor environmental quality. C. Energy and atmosphere. D. Materials and resources. Answer: C. When addressing water use for laundry equipment, the energy and atmosphere category must be addressed in conjunction with the water efficiency category. Water use directly affects energy use because it typically takes gas or electricity to heat the water and to move the water to and from the building. In particular, heating water requires a substantial amount of energy that must be accounted for in efficient designs. Question 12. When addressing increased ventilation strategies to increase the overall quality of indoor air, which of the following categories must also be addressed besides the indoor environmental quality category? A. Sustainable sites. B. Indoor environmental quality. C. Energy and atmosphere. D. Materials and resources. Answer: C. When addressing increased ventilation strategies to increase the overall quality of indoor air, the energy and atmosphere category must be addressed in conjunction with the indoor environmental quality category. Increased ventilation strategies, while important for increasing the overall quality of indoor air, typically require a corresponding increase in vac energy use unless carefully designed. Question 13. When addressing interior color schemes for a project, which of the following categories must also be addressed besides the materials and resources category? A. Sustainable sites. B. Indoor environmental quality. C. Energy and atmosphere. D. Materials and resources. Answer: C. When addressing interior color schemes for a project, the energy and atmosphere category must be addressed in conjunction with the materials and resources category. Interior color schemes can significantly influence energy use. Light color surfaces reflect more light than dark surfaces and can reduce the total amount of lighting power necessary to maintain the intended lighting levels. Question 14. Which of the following is not a method that can net significant lighting energy savings? A. Enable individual lighting controls for occupants. B. Provide dimming capability on light fixtures. C. Specify line voltage lamps. D. Maximize the use of day lighting. Answer: C. Specifying line voltage lamps for incandescent fixtures is not a method that can net significant lighting energy savings. Lighting to meet the needs and preferences of building occupants is the main consideration to ensure the use of lighting in the space requires minimal energy. Allowing for individual lighting control and dimming capacity prevents the waste of excess lighting from when only a small area or level of light is required. Question 15. The design team is working on strategies to reduce the overall energy demand for the project. Strategies to reduce energy demand are all of the following except: A. Issue a survey to end users of energy-conserving activities performed and average time spent performing those tasks. B. Install meters on the project to monitor energy use. C. Highly insulate the building envelope. D. Minimize glazing. Answer: D. Minimizing glazing is not one of the strategies to reduce the overall energy demand for the project. In order to take advantage of the free energy provided by daylighting, substantial areas of glazing must be used to allow the light into the building. Question 16. Free energy can be utilized in buildings in all of the following methods except: A. Daylighting. B. Natural ventilation. C. An external thermal storage system. D. Passive systems. Answer: C. An external thermal storage system is not one of the methods for utilizing free energy in buildings. However, using the building mass as a thermal storage system is. Many building sites have the potential to satisfy the majority of human needs through passive systems. Daylighting prevents the need for artificial lighting during sunlit hours. Natural ventilation, such as operable windows, allows fresh air circulation while minimizing the required capacity of the HVAC system. Well-insulated walls designed to reflect light in the summer and absorb it in the winter will help minimize heating and cooling energy needs. Question 17. Strategies for passive design include all of the following except: A. Plan for open spaces to maximize natural daylight. B. Design for operable windows to allow natural ventilation. C. Use concrete material to absorb the heat for the building. D. Install controls to allow individual occupants to operate their lighting. Answer: D. Installing controls to allow individuals occupants to operate the lighting is not one of the passive design strategies. The idea of passive design goes back to using the natural attributes of the site. Lighting control is a design that goes hand in hand with daylighting, as it allows occupants to only use as much artificial light as they need, but it is not itself a passive system. Buildings that provide access to natural daylight can achieve significant lighting energy savings simply by using the sun instead of artificial lighting. Question 18. Energy efficiency strategies to be considered for a project to reduce energy demands includes all of the following except: A. Provide appropriate insulation based on local climatic factors of the project location. B. Install premium mechanical systems. C. Specify Energy Star appliances. D. Minimize glazing on the envelope system. Answer: D. Minimizing glazing on the envelope system is not one of the considerations for energy efficiency in buildings to reduce energy demand. Taking advantage of natural sources such as daylight to obtain free energy is one of the fundamental principles to reduce the energy demand. Question 19. Wind turbines, as a renewable energy source, generate current to the inverter to convert the power into alternating current. A. Direct. B. Indirect. C. Electric. D. Reverse. Answer: A. Wind turbines generate direct current to the inverter to convert the power into alternating current. All households must be provided with alternating currents for use, which require the power generated from wind turbines to be converted. Question 20. Project sites in altitudes can generate significant electricity using photovoltaic panels and reduce their energy use for hot water by using solar hot water heaters. A. High. B. Low. C. Negative. D. Pressure. Answer: B. Project sites in low altitudes can generate significant electricity using photovoltaic panels and reduce their energy use for hot water by using solar hot water heaters. In general, sites at lower altitudes have access to more direct sunlight, making it easier to generate electricity via photovoltaic panels. Question 21. The standard increment of electricity is the A. Kilowatt hour. B. Kilowatt minute. C. Kilometer hour. D. Kilometer minute. Answer: A. The standard increment of electricity is the kilowatt hour, kWh. This represents the amount of electricity that would be put out by a source of energy generating a constant flow of 1 kilowatt over the time period of 1 hour. Question 22. The levels of ongoing energy performance established in the owner's project requirements are determined at the beginning of design and establish the building's requirements. A. User. B. Functional. C. Technical. D. Whole building system. Answer: B. The levels of ongoing energy performance, as part of the owner's project requirements, are determined at the beginning of design when establishing the building's functional requirements. During design and throughout construction and operation, the OPR should be used as a benchmark for achievement when evaluating design options and functionally testing the systems once constructed. Question 23. Strategies for ongoing energy performance include all of the following except A. Providing staff training resources. B. Performing periodic maintenance. C. Using an integrative design approach. D. Implementing incentive programs for building users. Answer: C. Using an integrative design approach is not one of the strategies for ongoing energy performance. Integrative design approach is encouraged to be used at the beginning of design and throughout construction and is used to determine the strategies for reducing environmental impact prior to the completion of the project. Once the building is occupied, To ensure ongoing energy performance, users should be educated about and incentivized to minimize energy use. Regularly scheduled maintenance and recommissioning should be used to ensure systems are functioning optimally and to preempt problems before they are prohibitive to repair. Question 24. What is the first step a project team should consider when trying to save energy? A. Use on-site renewable energy. B. Reduce energy demand. C. Adopt energy efficiency measures. D. Install submetering equipment. Answer: B. Reducing energy demand is the first step a project team should consider when trying to save energy. Reducing energy demand is the primary function of passive systems. Passive systems tend to be the least complicated and least costly systems to construct and operate compared to their net energy and operating expense savings. When that option has been exhausted, a project team should implement energy efficiency measures such as installing high-performance equipment, then consider the use of renewable energy, and lastly installing the submetering equipment to maintain building performance. Question 25. Equipment types that use British Thermal Units, BTU, as the standard measure of energy include all of the following except: A. Radiant heaters. B. Server room air conditioner. C. Gas furnace. D. Mesh line. Answer: D. Mesh line is not one of the categories of equipment types that use the BTU as the standard measure of energy. Mesh line is a UK commercial catering and food service equipment manufacturer and is not an equipment type. Question 26. Chillers are devices that remove heat from typically as part of a refrigeration system used to cool and dehumidify buildings. A. Air. B. Inert gas. C. Liquid. D. Glass. Answer: C. Chillers are devices that remove heat from liquid, typically as part of a refrigeration system used to cool and dehumidify buildings. This liquid can then be circulated through a heat exchanger to cool air or equipment as required. Question 27. A compact fluorescent lamp, CFL, is a small fluorescent lamp used as a more efficient alternative to incandescent lighting and is also referred to as all of the following except: A. PL. B. Twin tube. C. Biax lamp. D. Triax lamp. Answer: D. Triax lamp is not one of the terms that refers to compact fluorescent lamps. Compared to conventional incandescent lamps giving the same amount of visible light, CFLs use less power and have longer rated life. They have a higher purchase price, but their longer life and lower energy consumption allow for a lower life cycle cost. However, CFLs contain mercury, so their disposal is more specialized and more care needs to be ensured to prevent bulb breakage. Question 28. Greenhouse gas emissions per capita is a measurement of a community's total greenhouse gas emissions divided by the total number of A. Automobiles. B. Buildings. C. Residents. D. Users. Answer: C. Greenhouse gas emissions per capita is a measurement of a community's total greenhouse gas emissions divided by the total number of residents. In a study in 2000 based on data for carbon dioxide, methane, nitrous oxide, perfluorocarbon, hydrofluorocarbon, and sulfur hexafluoride emissions compiled by the World Resources Institute, the United States ranked 14th for the highest greenhouse gas emissions per capita. Question 29. To qualify for the Energy Star rating, a building must score greater than A. 25, B. 50, C. 75, D. 85. Answer: C. To qualify for the Energy Star rating, a building must score greater than 75 on the Energy Star benchmarking index. Energy Star rating is a measure of a building's energy performance compared with that of similar buildings, as determined by the Energy Star portfolio manager. A score of 50 represents average building performance. Question 30. The energy consumption of a building is normally calculated in British thermal units divided by the number of underscore in a building. A. Square feet. B. Subdivisions. C. Watts. D. Floors. Answer: A. Energy consumption in a building is typically measured in British thermal units, BTU, per hour per square foot. These measurements are usually provided as BTU/FT2 per annum, but can also be shown as per hour, day, month, or year. A BTU is the amount of energy required to raise the temperature of 1 pound of water by 1 degree Fahrenheit at a constant pressure of 1 atmosphere. Question 31. Equipment, distribution systems, and terminals that provide the processes of heating, ventilating, or air conditioning follow the standards of A. ASHRAE, B. ANSI, C. EPA, D. Energy Star. Answer: A. Equipment, distribution systems, and terminals that provide the processes of heating, ventilating, or air conditioning follow the standards of American Society of Heating, Refrigerating, and Air Conditioning Engineers, ASHRAE. ASHRAE is an international organization and fulfills its mission of advancing HVAC systems to serve humanity and promote a sustainable world through research, standards writing, publishing, and continuing education. Question 32. California's Title 24 is the underscore standard for residential and non-residential buildings. A. Energy efficiency. B. HVAC efficiency. C. Lighting efficiency. D. Building envelope efficiency. Answer: California's Title 24 is the energy efficiency standard for residential and non-residential buildings. Title 24 is Part 6 of the California Code of Regulations established in 1978. It was developed in response to a legislative mandate to reduce California's energy consumption. Question 33. Green buildings and neighborhoods can reduce demand for energy by capturing natural, incidental energy. One strategy is configuring roads, infrastructures, and landscaping so that buildings A. minimize solar gain in summer and maximize it in the winter. B. Minimize solar gain all year round. C. Minimize solar gain in winter and maximize it in the summer. D. Maximize solar gain all year round. Answer A. Roads, infrastructures, and parcels can be configured so that buildings minimize solar gain in summer and maximize it in winter. This way the building needs less cooling in the summer, since it is configured to receive less heat from sunlight, but also needs less heating in the winter because it is receiving more sunlight. For example, eaves and deciduous trees can prevent light from entering windows in the summer when the sun is high and the trees are leafy. In the winter, the trees will be bare and the sun lower, allowing sunlight to enter the building. Question 34. The LEED for Homes rating system adjusts the point thresholds for the certified, silver, gold, and platinum rating based on home _ A. Location. B. Size. C. Orientation. D. Energy demands. Answer B. The LEED for Homes rating system adjusts the point thresholds for the certified, silver, gold, and platinum rating based on home size. Energy demand typically increases directly with building size. The more square feet in a building, the more energy it consumes. Therefore, a larger house will have a larger threshold for energy consumption, though its energy use per square feet has no reason to increase. Minimizing the size of the building overall, though not a popular choice, is an easy way to reduce energy use. Question 35. When addressing the envelope for achieving energy efficiency, buildings shall be properly weatherized, which means buildings should be secure against all of the following except A. Sunlight. B. Precipitation. C. Wind. D. Air pollution. Answer D. Air pollution is not one of the factors being secured from a building when properly weatherized. Weatherization is the practice of protecting a building and its interior from the elements, particularly from overexposure to sunlight, precipitation, and wind. It also involved modifying a building to reduce energy consumption, minimize energy loss, and optimize energy efficiency. Question 36. In order to take advantage of passive design opportunities, all of the following considerations must be taken except A. Building orientation. B. Material selection. C. Window location. D. Roof pitch. Answer D. Roof pitch is not one of the considerations taken for passive design opportunities. Passive design is the use of natural resources of sun and wind to heat, cool, and illuminate a building without additional energy. Proper building orientation, selection of materials, and location of windows can allow a building to be warm in the winter, stay cool in the summer, and capture daylight. Roof pitch is important for directing precipitation runoff. Question 37. When installing high-performance mechanical systems, it is recommended to apply life cycle analysis to the trade-offs between _ and _ A. Energy efficiency, indoor air quality. B. Initial capital, operating costs. C. Investment, environmental impact. D. Operation, maintenance costs. Answer B. When installing high-performance mechanical systems, it is recommended to apply life cycle analysis to the trade-offs between initial capital and operating costs. The life cycle analysis is the investigation and evaluation of the environmental impact of a given product or service caused or necessitated by its existence. High-performance mechanical systems generally require more initial capital investment, but have the possibility of paying for themselves in reduced operating expenses over the building's life cycle. It is important to consider life cycle costs when deciding on high-performance systems, both to ensure that you are not giving up substantial long-term savings due to higher initial costs, but also to ensure that the higher initial costs will indeed be made back through normal operating usage. Question 38. Energy Star applies to all of the following equipment as a measure for high efficiency, except A. Computers, B. Air conditioners, C. Power adapters, D. Cellular phones. Answer D. Energy Star applies to computers, air conditioners, and power adapters as a measure of high efficiency, but not to cellular phones. Energy Star is a standard for energy-efficient consumer products maintained by the EPA and U.S. Department of Energy. Devices that carry the Energy Star logo, such as computers, air conditioning units, and power adapters generally use 20 to 30% less energy than required by federal standards. Question 39. LED-based traffic signals will reduce energy demands from neighborhood infrastructure. LED stands for A. Light-emitting diode, B. Light electroluminescence degree, C. Light electronic device, D. Light energy discharge. Answer A. LED-based traffic signals will reduce energy demands from neighborhood infrastructure. LED stands for light-emitting diode. LED is a semiconductor light source used in many devices and is increasingly used for lighting. LED-based lighting is high in efficiency, as measured by its light output per unit power input. However, in areas that receive a lot of snowfall, it has been observed that LED-based traffic signals fail to melt the snow that obscures them, which is an advantage of incandescent signals. Question 40. To capture efficiencies in scale, design district heating and cooling systems in which multiple buildings are part of a loop. A. Single, B. Secondary, C. Closed, D. Open. Answer A. To capture efficiencies in scale, design district heating and cooling systems in which multiple buildings are part of a single loop. This allows high-output equipment with economies of scale to be used. However, individualized controls still need to exist to allow buildings to adjust the artificial climate to their needs. Question 41. An example of thermal energy storage is to generate at night to be used the next day. A. Hot water, B. Renewable energy, C. Non-renewable energy, D. Heat mass. Answer A. An example of thermal energy storage is to generate hot water at night to be used the next day. This takes advantage of off-peak energy, which is cheaper than using energy during peak demand. An even more efficient example would be to use solar power to heat the water during the day for use at night. Question 42. The purpose of using energy simulation is to A. Calculate Title 24. B. Prioritize energy efficiency opportunities. C. Determine the sun path. D. Evaluate high-performance systems. Answer: B. The purpose of using energy simulation is to prioritize energy efficiency opportunities. Energy simulation is a complex computer model that takes a calculated view of the building, as well as usage and weather patterns to determine how energy is being used, which allows efficiency priorities to be determined. Computer-generated energy simulation is the key to designing cost-effective envelope and vac systems for buildings. Question 43. To ensure that the building systems are functioning as designed and in support of the owner's project requirements, it is best to monitor and verify performance through all of the following methods except A. Control systems. B. Building automation system. C. Commissioning. D. Operation costs auditing. Answer: D. Operation costs auditing is not one of the methods used to monitor and verify performance. To ensure that the building systems are functioning as designed and in support of the owner's project requirements, it is best to monitor and verify performance through control systems, the building's automation system, and commissioning. Question 44. Process energy is not subject to the LEED minimum performance requirements. Examples of process energy include all of the following except A. Elevators. B. Office equipment. C. Kitchen cooking. D. Heating systems. Answer: D. Heating systems are not examples of process energy. Process energy runs office equipment, computers, elevators and escalators, kitchen cooking, and miscellaneous items that are used by the occupants and not inherent to the building itself. Process energy is not subject to the LEED minimum performance requirements. Question 45. Geothermal energy is power extracted from heat stored in the A. Wave. B. Earth. C. Biomass. D. Wind. Answer: B. Geothermal energy is power extracted from heat stored in the earth. This geothermal energy originates from the original formation of the planet, from radioactive decay of minerals, from volcanic activity, and from solar energy absorbed at the surface. Geothermal energy is a valuable renewable energy source, but one that must be used in moderation. If too much geothermal energy is extracted from a given area, the lack of warmth in the soil will make it difficult for vegetation to grow. Question 46. Biomass, a renewable energy source, includes all of the following biological materials except A. Wood. B. Gas. C. Alcohol fuel. D. Natural gas. Answer: D. Natural gas is not one of the forms of biomass. Biomass energy is generated from biological material from living or recently living organisms such as wood, gas from decaying matter, and alcohol fuel derived from plant matter. Biomass is commonly plant matter grown to generate electricity or produce heat. Question 47. Energy Star was developed by A. EPA, B. ASHRAE, C. ANSI, D. USGBC. Answer: A. Energy Star was developed by EPA, in conjunction with the U.S. Department of Energy, and is one of the most widely used equipment energy efficiency benchmarking systems. Question 48. Strategies for maintaining energy efficiency include all of the following except A. Adhering to owner's project requirements. B. Providing staff training. C. Conducting preventative maintenance. D. Commissioning. Answer: D. Commissioning is not one of the strategies for maintaining energy efficiency. Adhering to the owner's project requirements, providing staff training, and conducting preventative maintenance ensures energy efficiency after the project is complete. Recommissioning, the periodic testing and measurement of system efficiency, is also important to ensure that systems continue to work well as the building ages. Question 49. Monitoring involves comparing building performance measurements with predictions from a calibrated energy simulation or underscore. A benchmarking tool. B. ASHRAE standards. C. Web-based tool. D. Commissioning. Answer: A. Monitoring involves comparing building performance measurements with predictions from a calibrated energy simulation or benchmarking tools. The EPA's Energy Star is one of the most widely used benchmarking systems. Question 50. Energy Star Portfolio Manager users enter data on their underscore and underscore usage, along with other supporting information into a web-based tool to evaluate the performance of the building against that of others with similar characteristics. A. Electricity, natural gas. B. Energy, fuel. C. Lighting, coal. D. Renewable energy, oil. Answer: A. Energy Star Portfolio Manager users enter data on their electricity and natural gas usage, along with other supporting information into a web-based tool to evaluate the performance of the building against that of others with similar characteristics. This is an exceptionally useful, free tool for gauging the relative performance of buildings. Thank you for watching.